there are many computer simulations out there that model the hydrodynamics of gas and fluids. Today I'm going to explain how we do that. This is Monterey. Welcome to my cosmic kingdom. The first step in doing computer simulations goes through a process that is called discretization. This process consists in changing the continuous nature of a physical magnitude like density of or temperature into discrete amounts that can be processed by the computer. To give you an example of this process, I'm just sitting here with this sphere. This is not technically a sphere because it's made of small triangles, as you can see, but in the end it creates the illusion. It gives you the shape of a sphere, just making small flat triangles. I model molecular clouds that are basically entities made of gas, but any hydrodynamical simulation can use any fluid, such as water. Here in the University of Surrey we have a lovely pond that is going to help me to explain how we do that. The first task here is just to discretize the pond. So we need to convert the continuous nature of the water of the pond into a discrete set of numbers that can be computed. For doing that, there are several methods, but today I'm going to talk about grid-based methods. So what we do is just convert all the pond into a big grid, and we assign to each cell of the grid the properties we want. So for example, if the pond is at 10 Celsius, we just assign the temperature to every single cell of the grid. Imagine that there is a source of heat in the pond and the temperature changes. We will just give a different temperature to each cell of the grid. By doing that, we can just now plug these numbers into the computer. Obviously, just for these simulations to work, that grid size has to be very little. But there is another improvement you can make, and what you can make is just changing the shape of the grid, changing the size of the grid accordingly to what you need. In my simulations of molecular clouds, we normally use a smaller size for the denser area so that we can resolve the fun physics that happens there. Imagine that we want to study in more details the habitat of the ducks. So you will see there are certain vegetation behind me, and here's where the ducks normally live. So we can increase the resolution there, and we can model it. We need to solve the equations of these magnitudes like density, temperature, or pressure, and evolve them over time. And for that we use a computer, and now that everything is discretized, we use very complicated numerical methods to integrate them fastly and accurately. The pond is a very boring example. It's very beautiful, but it's quite boring because obviously you don't have, the pond has always the same shape, the water, you cannot compress water, so it's kind of boring. But if you have a look at how the clouds move, it's a good example because they don't stay at the same place in the time, and you need to integrate them, and they change shape, they change density, they change even the composition. And all of this can be modeled using a program like the ones I'm using to model like another kind of clouds in the galaxy. So I think that is all for today. I just wanted to give you a brief outline how we create these amazing simulations here in the University of Surrey. There are more methods than the one I described today. That is a grid-based method. There are methods that use particles to model the water, but I think I will leave those ones for another episode. Please follow me on Twitter, Facebook, and YouTube, and bye-bye. See you next week.